So in this session, important session, ray optics. Ray optics. So ray optic means what comes to your mind immediately? Ray optics. What is ray? What is optics?
Rays are come from sun.
Huh?
Rays are comes from sun.
No, it's not that rays. That's different. Ray means generally refers to. Okay, what comes to your mind?
Ultraviolet ray, infrared ray, UV ray.
UV rays. Okay. Some ray. Okay, that's okay. Correct. Okay. Then optic means.
Mirror.
Yeah, mirror. Now only you told correctly after a long time. So the ray optic means this is a type of waves where different waves is there. Okay, different waves is there. Then optics means lens. Basically it belongs to lens. Okay, so this for this chapter. So this chapter is ray optics and optical instrument. He will tell us how the any waves when focused on the lens, how it will be. It could be reflected. It could be refracted. It could be reflected or refracted. So reflected means it is coming back. Reflection. Refracted means it's passing through the lens. So this only the main two possibilities: reflection and refraction. So this based on this principle only. Based on this principle, the optical instrument is designed. Optical instrument is designed. Because you know, right? So right when you are born, to your old age, you can see your vision, right? The vision will not be affected when you are baby or when you are a old person. Old no, when you are a baby and when you are aged person, your vision will be normal. But in some, but for normally everybody, for 80% will be everybody is normal. Okay, for a few percentage of them, 20% of them, aged person, you can not in the aged person, in the young itself, you have some problems, right? Some problems will arise some problem will arise due to eye. So your vision will get affected. Your vision will get affected. So they will wear the specs. So what are the two types of specs they will wear? For which problem they will wear?
Eye problem.
Yeah, eye problem. What is the problem? Eye problem only. What is the problem? Two types of problem. Huh?
Nearer version.
What is the name of the problem?
Convex, concave.
No, that's different. That's different. The lens they are using is convex. What is the problem in their eye? Short sight and long sight. Short sight,
and
long sight. So something is there in their problem eye. It's not for the aged person. It's for young itself. Even a few babies of 10 years old, they are having that problem. It's not about aged person of 80, 90. You will get on the when you are aged around 80, 90. When you are baby, when you are baby itself, around 10 years old, around 10 years old, they will be getting that problem. Short sight, long sight, something. So to rectify that problem only, so they will wear specs. So this specs is varied now. So the specs is varied. To why you need to see why you need to vary the specs to get the clear vision. The vision should be clear. For that, what is the only thing we have to do is we have to wear the specs. Now whether short sight or long sight, the vision is now clear. So the vision is accurate. So some problem, eye problem is there. So some problem is there, eye problem is there. So the vision is accurate. So this is the most things that. So something. So the lens that we are wearing now the problem comes. Now only the main question comes. So the lens is there. We already having the lens in your eye. Okay, we are in your lid, in your eyelid. In your eyelid there is a lens is there. Now that lens cannot able to properly able to see the vision. So you have some problem in the lens, not in the eye, from the problem in the lens. So to overcome that only, we are wearing the lens. We are wearing the specs. So which is short sight or long sight. Now the vision is very clear. So the vision is very clear. Now, so we have overcome all the difficulties. So we have now it's very common. It's very common. You can go to any shop, you can go to any hospital, consult doctors and get the appointment, and you can visit shops, and there are plenty of shops for this optometrist where you get this lens specs at the no time. At the no time you can get the specs and you can see the clear vision, whether it's long sight or short sight. So this this is the main important. This is one of the main important topic to that only we are going to see how this problem is rectified. What lens for short sight, what lens we are going to use. For long sight, what lens we are going to use. So this and all we are going to see in this chapter. So in this scenario, so now whether it's a newborn baby or an old person, the eye remains same, right? Eye remains the same. Only the visions sometimes only 20% of them of the vision problem. Okay, here we can skip the 20% of the now we are rectifying the 25%. So 80 plus 20, 100% is no problem now, because 80% is normal, 20% they are wearing the specs. 20% of them they are wearing the specs. So after wearing the specs, now the vision is everything is clear. So everybody is clear. But some of the things they cannot see, which you can't see from your eye. Which you can't see from their naked eye. Some of the things which you can't see.
Rays.
Huh?
Rays.
No, rays you can't see in anything. There is no purpose, right? Rays. What is the purpose of seeing that?
Waves.
Waves. Waves you can't see in it. Which waves? None of the waves you can't see it. Waves is nobody can see the waves. What is the purpose of seeing the waves? Huh?
Microorganism.
Microorganism. It comes physically microorganism, because microorganism, plenty of viruses is there. It's a coronavirus. The coronavirus devastated. Can you able to see what is the size of coronavirus? Size of coronavirus. All the virus will be in the nanometers. Nanometers. All the virus will be in the nanometers. So you can't see nanometers or more specifically micrometers. So you can't see in your naked eyes. So you need the microscope. So microscope was designed to view the microorganism, to see its structure, to illustrate the structure, how the things were. For example, the microorganisms, if you take any cell you can take how the nucleus, where is nucleus is located, where is mitochondria located, where is endoplasmic is located. So everything we can see in the microscope. In the same scenario, some of the objects which is very long distance that we can't see. So what is that longest distance that we can't see? Longest distance. Some objects which is in the very long distance we can't see. What is that? Huh? Yes, star, planets, some of the things, asteroids, everything which is very far from here. So for example, recently also, this is 2022 May, recently 2020 May to 2020 May, exactly 2 years. 2020 May, 2022 May, one of the asteroid crossed Earth, which is first it was crossed, it has crossed the Earth, then it is completed its orbit cycle, then it has crossed last May first week only it has crossed May first week it has crossed the Earth, again it's Earth. So the distance is in 2020 that is crossed, it was very short distance, and when it was crossed 2022 year, last few days back, because it was short, distance is very short. Distance is very long. So that in 2020 only, the distance is very short. So at the time 2020, it has crossed Earth, all the planet has crossed. It has crossed the entire Sun. Then it came back. Again it came back. Again it's crossing again it's crossed the Earth in the very far distance. But when it's crossed in the 2020 only, it is very near a short distance. So we can able to see that you can able to see its vision very clearly via telescopes. Where here we are having the telescope in Chennai. Birla Planetarium. There is a telescope there in Chennai. That planet, that asteroid which crossed our Earth, you can view it in the Birla Planetarium. It was viewed in the, it was viewed by everybody. Everybody viewed it, 2020 and 2022. Recently, just few weeks back, it is crossed the Earth, but it's very far distance. When it's crossed 2020, they viewed it in the they can see it clearly, but now they in telescope also they can't see it because it's very far, so you can see. So that means that the things we are now we started from the thing, we started from the what we started. Finally ended up in the rays, ray optics, the rays which is passed through the various lens has various application. Like it is used in the construction of microscope, which is small organism, nanometers or micrometers. It will be ranges around that range. That also can be seen in by a microscope. Then a distance object, which is a giant asteroid, which is crossing, which is very far. Millions of miles. That also that is vision by telescope. So microscope and telescopes both are same principle only, but application is different.
Yes.
So based on this particularly, now we go for ray optics and array optics. The light can pass from any wave can pass from one point to another. The wave can pass from one point to another. The wave can pass from one point to another. This path is called ray of light. Or you can put light itself. Light can pass from one point to another. Light wave can be passed from one point to another. This path is called ray of light. This is called ray of light. A bundle of such rays is called beam of light. A bundle of such, first one you put as light wave. The light wave will travel from one point to another, okay, and along a straight line, in a straight line, along a straight line, in a straight line. The light wave will travel from one point to another in a straight line. Okay? And beam of a branch of bundle of this such rays, a bundle of such rays is called beam of light. Bundle of such rays is called beam of light. Bundle of such light is called beam of light. Okay? Yeah, take this. This is the incident ray, normal, reflected ray. Okay? You take this?
Yes, sir.
Huh?
Yes, sir.
Then focal length of the mirror. Focal length of the mirror. The focal length of the mirror. Okay? In the mirror, the reflected rays appears to diverge from a point F. The reflected rays appears to diverge from a point F on its principal axis.
Yes, sir.
The reflected rays appears to diverge. The reflected rays appears to diverge. Reflected rays appears to diverge from a point F on its principal axis. From point F on its principal axis. This point is called principal focus. This point is called principal focus. This point is called principal focus. So, this point is called principal focus, no? If the parallel beam of light were incident, if the parallel beam of the light were incident, if the parallel beam of the light were incident, making some angles with principal axis, okay, if the parallel beam of light were incident making some angle with the principal axis, the reflected rays would converge. Reflected rays would converge from a point in a plane, from a point in a plane through F. What is F?
Focal length.
Focal length. from a point in a plane through F, from a point in a plane through F, from a point in a plane through F, normal to the principal axis, normal to the principal axis, from a point in a plane through F, normal to the principal axis. Normal to the principal axis, and this is called focal plane of the mirror. This is called focal plane of the mirror. This is called focal plane of the mirror. So what is the definition now?
If the parallel beam of the light, the incident making some angle with principal axis, the reflected rays would converge from a point in a plane through F, normal to the axis. This is called focal plane of the mirror.
Focal plane of the mirror. The distance between the focus F and the pole P, the distance between the distance between the focus F and the pole P of the mirror is called focal length of the mirror. Distance between the focus F and the pole B, pole P, pole P-O-L-E, pole P of the mirror is called the focal length of the mirror.
The distance between focus F
and pole B, P-O-L-E, pole B of the mirror is called the focal length of the mirror. It's called the focal length of the mirror. Focal length of the mirror. So denoted by F. Denoted by F, and F is equal to R by 2. F is equal to R by 2. R is the radius of curvature of the mirror. R is the radius of the curvature of the mirror. R is the radius of the curvature of the mirror. What is the radius of the R is the
radius of the curvature of the
mirror. Oh, that's all. F is equal to R by 2, where R is the radius of the curvature of the mirror. Okay, so then we go for mirror equation. Mirror equation. Mirror equation, okay? If any two rays merging at the one point, if any two rays are merging at one point, if any two rays are merging at one point if any two rays are merging at one point, and this point is called the point of intersection, and this point is called point of intersection. So it's called, this point is called the point of intersection. Thus the image obtained from this point due to reflection at the mirror, as following properties. As following properties. First one, the ray from the point which is parallel to the principal axis. Ray from the point which is parallel to the principal axis. The ray from the point which is parallel to the principal axis. Ray from the point which is parallel to the principal axis. The reflected ray goes through the reflected rays goes through focus of the mirror. So this fourth point, what I am going to tell, you have to understand thoroughly. If you understand thoroughly only, we can go for next step. Okay? I will explain you after this. I will explain this after this point. I will explain everything. If you don't understand, tell me once again. I will explain you. Okay? The rays from the point which is parallel to the principal axis. The reflected rays goes to the focus of the mirror. The reflected rays will go to the focus of the mirror. Reflected rays goes to the focus of the mirror. The rays passing through the center of the curvature of the concave mirror. The rays passing through the center of the curvature of the concave mirror. The ray passing through the center of the curvature of the concave mirror. The rays passing through the center of the curvature of the concave mirror. The rays passing through the center of the curvature of the concave mirror are appearing to pass through it for a convex mirror. And the reflected rays simply retrace the path. The reflected rays simply retrace the reflected rays simply retrace the path. Reflected rays simply retrace the path.
Simply
retrace. Retrace the path. Retrace. R-E-T-R-A-C-E-S. Retrace the path. The rays passing through the center of the curvature of the concave mirror or appearing to pass through it for a convex mirror, the reflected rays simply retrace the path. The ray passing through the convex of the concave mirror, the ray passing through the focus of the concave mirror, focus of the concave mirror, the rays passing through the focus of the concave mirror are appearing to pass through the focus of convex mirror. This is third point.
Okay, sir. Are appearing?
Are appearing to pass through the focus of the convex mirror, or appearing to pass through the focus of the convex mirror. The reflected ray is parallel to the principal axis. The reflected ray is parallel to the principal axis. The reflected rays is parallel to the principal axis. Then 3 points over, no? 3 points over.
Yes, sir.
Fourth one, the ray of incident. The third point is, I will repeat once again. Third point, the ray passing through the focus of the concave mirror or appearing to pass through the focus of the convex mirror, the reflected ray is parallel to the principal axis. Then the fourth point is, a ray of incident at any angle at the point. The ray of incident at any angle at the pole. Ray of incident at any angle at the pole. Ray of incident at any angle at the pole. The reflected rays follows the law of reflection. The reflected rays follows the law of reflection. Follows the law of reflection. What is okay? Yeah, I will tell you everything. What is the law of reflection? Everything. So this is called mirror equation. Mirror equation. Okay, this is a rays passing it. This is a mirror. Okay, when it's passed to the mirror, it get reflected. It get reflected. Okay, so this is f. F is the point for your principal focus. What is the focal length? Huh? F is equal to what? R by 2. What is F? Focal length. So this is the focal length. The P from the point P to F is the focal length. Then from the N to the B prime, which is this is the point of mirror image, where the image is formed here. That's a V. Then from this point U, from this point to the B. B is a point of origin where the rays is set. That is U. So U, V, F. F, this is a mirror image, and this one is a is the image formation. A is A is image formation. This one M, P, N is a mirror. A is the image formation. M, P, N is a mirror. Okay, so this one is a race. A is a race. This one is a race. This one is a image. Image formation. This MPN is a mirror. Then U is a distance. What is U here? N to B. What is B here? B or A is the position of race. So from the mirror to the position of race is U. What is V here? Image. A is the image information. N is the distance from the mirror to the image formation. Then V is the focal point. Focal length to the lens. It's a F. That's all. So 1 by V plus 1 by U is equal to 1 by F. That's a mirror equation. Okay?
Yes, sir.
Now we have to go to 4 points. What 4 points? 4 points we took? That point is very, very important. How many points we took? 4 points, you know? First, now I will take the 4 points, okay? The ray from the point which is parallel to the principal axis, the reflected rays goes to the focus of the mirror. First one is the rays from the point which is parallel to the principal axis. Rays from the point, rays from the point which is parallel to the principal axis, which is parallel to the principal. This is the principal axis. This is parallel to the principal axis. The rays, see, this is the principal axis. Okay. First one is the rays from the point which is parallel to the principal axis. The reflected rays goes to the focus of the mirror. See the rays. This is the rays which is parallel to the principal axis. So it focus. It is passing through the focal length. It passes to the focus of the mirror. So it passing to the focus of the mirror. This one is, what is this one?
Mirror.
The ray passing through the center of the curvature of the convex mirror or appearing to pass through a convex mirror. The rays passing through the center of the curvature of the rays passing through the center of the curvature of the convex mirror. The reflected rays simply retrace the path. The reflected rays simply the rays which is passing through the center of the rays passing through the center of the curvature of the convex mirror. This point I think. The rays passing through the center of the curvature of the convex mirror is simply the reflected rays simply retrace the path. The reflected rays this passing to this ring, so it's this point. Simply retrace the path. Retrace means the what? Retrace means?
Same image.
Same image. Retrace means the same image. Then same thing, the rays passing through the focus of the convex mirror or appearing to pass through the focus of the convex mirror. The rays passing through the focus of the rays passing through the focus of the convex mirror. The reflected rays is parallel to the principal axis. The reflected rays is parallel to the principal axis. The reflected rays, the rays passing through the rays passing through the focus of the convex mirror. Focus of the convex mirror. The rays passing through the focus of the convex mirror. The reflected rays is parallel to the principal axis. The rays passing the first one is ray passing through the focus of the convex mirror. Focus of the convex mirror. So the rays passing through the focus of the convex mirror is simply is simply the reflected rays is parallel to the reflected rays. So this rays parallel to the principal axis. That is principal axis is this one. This one no, this one is a principal axis. No. So probably this is the thing. So this and this are parallel, I think. This and this is parallel. The rays passing through the focus of the convex mirror. The focus point is this one. So this point is parallel. That is the rays passing through the focus of the convex mirror. The rays passing through the focus of the convex mirror. The reflected rays is parallel to the principal axis, reflected rays. That is, yeah, this, the rays passing through this rays which is focusing here is parallel to the principal axis. Then ray of incident at any pole follows the law of reflection. Law of reflection is that is law of incident. This is law of incident, and you get reflected here. The incident light is the incident light, and the incident and the incident rays is get reflected rays. So the incident angle is theta, reflected angle is theta. So if you take this one is theta 1, this one is theta 2, theta 1 is equal to theta 2. This is the law of reflection. Okay? So we taken down everything, no?
Yes, sir.
We taken down everything, no?
Yes.
Now second phenomena. Second phenomena is refraction. Next is refraction. What is refraction? You know, right? What is reflection?
The rays passing through.
No.
They reflect.
No, rays.
No reflection.
Huh?
Reflection.
No. Ray. What is reflection? What is reflection first now?
Showing the same image.
No.
The rays are reflected.
The rays are reflected. Incident. That's why I told you. Just now I told you. The incident rays. This is a mirror. Something incident get reflected here. Here. That's a reflection. Reflection means the incident light will pass through the mirror. Refraction. Okay. Now comes the okay. That's why I told you. This is normal. So this is normal. This is theta 1. This is theta 2. So theta 1 is equal to theta 2. Okay. Here theta 1. This one will be theta 2. Theta 1 will be equal to theta 2. Okay. So this is reflection and this one is a
Refraction.
refraction. So the refraction, the dash of the refraction, the rate of propagation of the rate of the incident light get refracted through the medium. The incident light get refracted through the medium. The incident light get refracted through the medium. It's called refraction of the light. It's called refraction of the light. So the what I told you, the direction of
The incident light
the incident light get refracted through the
medium is called the refraction of light.
refraction of light. So what is refraction now? That means not this is not W, this is N, normal. So if you take one point, a light is incident with this normal, that is normal with respect to its theta 1. It got reflected, passing, reflected means passing through the medium. right, or passing through the medium. It has to pass through the medium. Then it is called theta 2. So this angle and this angle are equal. Theta 1 is equal to theta 2. The law of refraction follows two rules. The incident rays the incident rays and refracted rays all lie in the same plane. Incident rays to the refracted rays all lie in the same plane. Incident rays to the reflected rays all lie in the same plane. Incident rays to the incident rays and reflected rays all lies in the same plane. And okay, what is the first one?
The incident ray and refracted ray all lay in the
Not lie means lie in the same plane. Lie. And second one is ratio of the sine of angle of incidence is equal to ratio of the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is constant. Ratio of sine of angle of incidence to the ratio of the sine of angle of refraction is constant.
ratio of sine of
The ratio of the sine of incidence to the ratio of sine of refraction is constant. Sin I by sin R is equal to n. Just n. That's all. Is equal to n. Here n is constant or refractive medium, refractive index. This is also called as n is a constant or refractive index. Okay?
yes sir.
We want one example is sunset. One example is sunset
For which one, sir?
for refraction. One example is sunset. Okay, one example is sunset. The refraction of light through the atmosphere is responsible for refraction of light. Refraction of light through atmosphere is responsible. Refraction of light through atmosphere. Refraction of light through the atmosphere. Refraction of light through atmosphere is responsible for many interesting phenomena. It's responsible for many interesting phenomena. Sun is visible. Sun is visible a little. Sun is visible before sun is visible a little before the actual sunrise. Sun is visible before an actual sunrise. Still little is seen. Still a 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 little is seen. Little, L-I-T-T-L-E. Little is seen before the sunset. Due to refraction of light through atmosphere. Due to refraction of light through the atmosphere. Due to refraction of light through atmosphere. Due to refraction of light through the atmosphere. Due to refraction of light through atmosphere. What do you mean by this?
Sun is
Huh?
refraction. Example for refraction.
Refraction. Example: before sun rises, before sun rises, and before sunset. Before sun rises means what? Yeah. Before sun comes, that is before sunset. Before sunset means before sun arises. Before sunset, so we can see some sunlight, right? That's an example for refraction. Then before, after that is what? What is the timing for around then it be? What is timing? Sun rises before you can see light before sun arises means what is the timing?
4, 5.
Not 4.
5:40 or
Yeah, around that time, around 5:30. 5:30 to 6, because 6 o'clock sun rises, 5:30 to 6, but you can see the sunlight. So that is the meaning. Then even sunset means before or after sunset. Sun will set by 6 o'clock, 6 to 6:30. Because 6:30 you can see fully dark. We want that timing, that sunlight after sunset, which is 6 to 6:30. Okay, so the similar trend now go for internal reflection. Internal reflection. Internal reflection. When a light travels from an optical denser medium, when a light travels from the optical denser medium, when light travels from the optical denser medium, when light travels from the optical denser medium to a rarer medium, to a rarer medium, a partial of light is reflected to the same medium. A partial of light is reflected to the first medium, and another partial is another partial is reflected to the second medium. Partial of the first partial of the it's partial of the reflected partial of it.
Partial of the light is reflected to the first medium.
Reflected back to the first medium, and partial refracted to the second medium. Partial refracted to the second medium.
Reflected back to the first medium.
No, refracted to the reflected back to the first medium. Partial of it reflected back to the first medium.
First medium.
And a partial refracted to the second medium. A partial of it refracted to the second medium. Partial of it refracted to the second medium. So this reflection is called internal reflection. Another when light get reflected by a surface, no, that was over, no? Over. When okay, just tell. When light
travel from the optical denser medium to the rarer medium, partial of light is reflected back to the first medium and partial of it refracted to the second medium.
Partial of it refracted to the second medium. Second medium, and this is called internal reflection. When light gets reflected by a surface, when light gets reflected by a surface, reflected by the surface, when light gets reflected by a surface, normally some fraction of it get transmitted. Normally some fraction of it gets transmitted. normally some fraction of it gets transmitted. So the intensity of the reflected rays is always less than the intensity of the incident rays. Intensity of the reflected rays is always less intense than the intensity of the incident rays. Intensity of the incident rays, the intensity of the reflected rays is always less than the intensity of the reflected rays is always less than the intensity of the incident rays. Less than the intensity of the
reflected rays
is always less than the
intensity of
incident rays. This is mirror, this is what incident, okay? This is incident, this is reflected, which will have higher intensity now. That's what it tells. Huh? No, incident will have higher intensity. That's what I told you. Okay? The incident of the reflected rays is always less than the intensity of the if this is less means which is greater than. If this is less,
Incident
rays will be the greater, that's all. It's always greater than the incident of the intensity of the incident ray. And this is called total internal reflection. Total internal reflection. This is called total internal reflection. Total internal reflection. Total internal reflection in nature. Total internal reflection in nature. Total internal reflection in nature. What is meant by nature? Total internal reflection. Character. Nature means its character. Nature means its character. First one is mirage. Mirage, M-I-R-A-G-E. M-I-R-A-G-E. During summer, the ground becomes hotter. The ground becomes hotter. During summer, the ground becomes hotter than the air at the higher level. Ground becomes hotter than the air at the higher level. Becomes hotter than the air at the higher level. Okay? The refractive index of the air increases with density. The refractive index of the air increases with density. Refractive index of the air increases with density. Hot air is less dense. Hot air is less dense. Hot air is less dense. And has smaller refractive index than cooler air. Hot air is less dense. Hot air is less dense and has smaller refractive index than the cooler air. Okay, so the hot air is less dense and has smaller refractive index than the cooler air. So cooler air will have a highest refractive index, higher refractive index. Next is diamond. For diamond, okay, the critical angle for diamond is very small. The critical angle for diamond is very small. Critical angle for diamond is very small. The critical angle for diamond is very small. Hence, once the light enters the diamond, once light enters the diamond, it is very likely to undergo. Once light enters the diamond, it is very likely to undergo total internal reflection inside it. It is very likely to undergo total internal reflection inside it.
Enters the diamond.
What is it?
Once the light enters the diamond.
Once light enters the diamond, it is very likely to undergo total internal reflection inside it. Very likely to undergo total internal reflection inside it. Very likely to undergo total internal reflection inside it. Okay, next is prism. Next is prism. Prism is designed to bend the prism is designed to bend the light by 90 degree or 180 degree. Degree or 180 degree.
Designed
Prism is designed to bend the light by 90 degree or 180 degree. To invert the images without changing their size. To invert the image without changing their size. Without changing the size. Used to invert the image without changing their size. Okay, so prism, you have diamond prism, then that is optical fiber.
Optical fiber.
What first one we seen?
Mirage.
Huh?
Mirage.
Mirage. Then diamond. Then prism. Then optical fiber. It is used extensively. It is optical fiber. Fourth one, the fourth application. It is extensively used for the transmitting audio and video signals. It is extensively used for transmitting audio and video signals through the long distance. Audio and video signal through long distance. It is optical fiber is extensively used for transmitting audio and video signal through long distance. Audio and video signal through long distance. Audio and video signal through long distance. It is extensively used for transmitting audio and video signal through long distance. Okay, optical fibers to make use of phenomenon of internal reflection. This way, it involves the principle of total internal reflection. It involves the principle of total internal reflection.
Optical.
No, it involves the principle of total internal reflection. Total internal reflection. It involves the principle of total internal reflection. Okay, so we have seen now what we seen?
Optical fiber.
No, optical fiber. Okay, what we seen?
Total internal reflection
In nature. Now we are going to see refraction of the spherical surface. Refraction at the spherical surface.
then refraction by a lens. Refraction of the spherical surface and refraction by the lens. Two we are going to see now. So, first one is, yeah, this one, what is this one?
Mirror.
Mirror. Yeah, this one important. Mirror, not, spherical mirror. Spherical mirror. And so the spherical mirror, if the this one is the U, which is mirror to the point, and this one is V. V is from the position to the distance. Okay, so U by V, R is a point from which the center of image. So by center of image. So this if the object is, this is the object, and if you say this is center of image, this is U is the distance, V is the distance, and N1 and N2 is the distance from the object, and N1 to the center of the image formation. This one is image formation, this one is object, by which this one is U, this one is V, and this is the center of formation. This one is the center, center. So this one is R. So N2 minus V, N2 minus V minus N1 minus U is equal to N2 minus N1 by R, which is R, this. Similarly, for lens is given by 1 by V minus 1 by U is equal to 1 by F, and for power of lens is given by P is equal to 1 by F. Then total power of the lens is equal to total power of lens is sum of the total power of the lens is equal to sum of the power of the all individual lens, P1, P2, P3 up to Pn. That's all. That means it could be anything. It could be many. So n is, what is n here? Infinity. N is it. So P is equal to P1, P2, P3 up to Pn. Okay? In a given prism, then refraction through a prism, refraction through a prism, refraction through a prism, refraction through a prism. In a given prism, light is passed through if a given light is passed through a prism, angle of the angle of refraction will deviate from the angle of incident. Angle of refraction will deviate from the angle of incident. Angle of
refraction
will deviate from the angle of incident. And this angle of deviation is called this angle of what is that? What is what I told you?
If the given light is passes through the prism, angle reflection will deviate the angle of incident.
Angle of refraction will deviate from the angle of thing, and this change in the angle, this change in the deviation, this change in the deviation is called angle of deviation. This change in the deviation is called angle of deviation.
Yes, sir.
So the angle of deviation is given by what is n here? What is n here? What is n here? Huh? Huh? Number of n. I just 1 or 2 pages go back. Refractive index. This one is the area of the prism. Total area of the prism, and this one is the refractive index. D equal to
Into A வந்து angle of deviation, sir.
into A. A is the area of prism.
Area of prism.
Dispersion by prism. Dispersion by prism. The phenomenon of splitting of light into different colors. The phenomenon of splitting of light into different colors. The phenomena of splitting of light into different colors is called dispersion. Phenomena of splitting of light into different colors is called dispersion. The phenomena of splitting of light into different colors is called dispersion. And this pattern is called spectrum of light. And what is the example of it?
Rainbow.
Rainbow. Example is rainbow. Rainbow is an example of dispersion of sunlight by water drops in the atmosphere. Dispersion of sunlight by the water drops in the atmosphere.
Dispersion of
Rainbow is an example of dispersion of sunlight by water drops in the atmosphere. Dispersion of sunlight by water drops in the atmosphere. In the atmosphere. This is phenomena due to combined effect of dispersion, refraction, reflection. This phenomena is due to combined effect of dispersion. This phenomena is due to combined effect of dispersion, refraction, due to dispersion, refraction, reflection of sunlight, refraction, dispersion, refraction, reflection. Okay? This phenomena is due to combined effect of dispersion, refraction, reflection of sunlight by the spherical droplet of the water. By spherical droplet of the water. Spherical due to spherical water droplet of the rain. By the spherical water droplet of rain. By spherical water droplet of the rain. By spherical water droplet of the rain. By spherical water droplet of the rain. Then now we go for optical instrument. What are the two optical instruments that we have? What are the two optical instruments that we have? I already explained you two optical instruments based on the lens type. Optical instrument, microscope and telescopes. So the microscope is the one to view the microorganism. Telescope is the one to view the distant object. Okay?
Yes, sir.
You take the microscope, telescope definition and uses. Then in microscope, the linear magnification M for image, the linear magnification M, linear magnification M for image formed at the point D. Linear magnification M for an image formed at the point D.
For an image,
For the image formed at the D, for the image at the point D, for the image at the point D, is given by M is equal to the linear magnification M for the image formed at the point D is given by M is equal to 1 plus D by F. What is M here? Linear magnification. D is the point D, which is distance from the magnification, and F is the
focal length.
okay. For a telescope, M is equal to F0 by Fe. What is F0? Focal length of the object. Here focal length of the eyepiece. Eyepiece. Focal length of the object divided by focal length of the eyepiece. Cost. Okay? Okay? That's all over. 5 minutes break.